Hello everyone, so today I'll be talking about 5G and if 5G is safe or not, because there's all these conspiracy theories and misinformation out there about how 5G is as dangerous as X-rays or something, and all this other nonsense that 5G is some kind of a they're going to use 5G as some kind of a conspiracy to try to control people or some other BS. But I'll be debunking all that in this video today. So 5G is just it's a very high frequency radio wave, and you can call this a microwave. So 5G, like 4G and 3G, which came before it, uses high frequency radio waves or microwaves. The microwaves range from 300 megahertz, mega means million, and 300 gigahertz, and giga means billion, so about 300 megahertz to 300 gigahertz. And that's at a wavelength of 1 millimeter to 1 meter in wavelength. So basically, as for the way that waves go, if you have a higher frequency, so as you can see on the diagram on the far right with the blue text, the high frequency wave, and below that you see a low frequency wave, and the low frequency wave has a longer wavelength. So you can see on the diagram where you see lambda. So that's wavelength. Lambda represents the wavelength. So the wavelength of the lower frequency wave has a longer wavelength, and the higher frequency wave has a shorter wavelength. So those are the properties of wavelengths, and you could calculate wavelengths by the formula you see. The lambda wavelength equals velocity divided by f, and f is frequency. And basically, and below that you see a sine wave and a cosine wave. If you took any physics class, you would use cosine and sine waves in solving problems in physics, and you would use stuff like that in math classes like trigonometry, calculus, and stuff like that. So the wavelength of a wavelength of a microwave is about 1 millimeter. That's about 0.039 inches to 1 millimeter. 1 meter, I'm sorry, which is about 3.3 feet. And 3.3 feet is equivalent to, that's about 39.6 inches. So I'll be talking about various types of 3G and 4G, 4G and 5G networks, and for 3G and 4G frequency range, that would be about 600 megahertz to 2.1 gigahertz. And for 5G frequencies, you get anywhere from 1 gigahertz to 100 gigahertz. So you have three types of 5G. You have the low band. This is the lower frequency, and that ranges from 600 megahertz to 1 gigahertz. And you got the mid band, which is 1 gigahertz to 6 gigahertz, and the high band is 6 gigahertz to 100 gigahertz. And basically, we do use microwaves to cook food, consumer grade microwaves, and they use about 2.45 gigahertz with a wavelength of 12.2 centimeters or 4.8 inches. So a regular microwave oven you buy at a retail store like Best Buys or you buy from Amazon or wherever, or consumes about 800 to 1800 watts of power. So your smartphone would probably consume anywhere from 3 to maybe 10 watts. And you can see the frequency of the microwave for your microwave oven is, it's way less than a 4G network, right? Well, it would be about the range of 4G network, something you're using right now, right? And the reason why your smartphone doesn't microwave your brain is because, like a microwave oven, is because your smartphone, the frequency may be high, like in the gigahertz range. However, the amplitude, as you can see in the wave chart, where you see lambda, and you see the amplitude, that line, that vertical line, the amplitude is pretty low because you're not using a lot of power in that, you know, in your smartphone or whatever. So obviously this isn't going to, there isn't enough power in there to like microwave you to the point where your brain's gonna explode. Like if you put food in the microwave, right? It heats up the water at a very high frequency. It vibrates the water molecules, and that causes the microwave oven to heat up your food or whatever, since it's heating up water molecules at a very high frequency. And that's how it works. And you have different types of waves, like radio waves, which you see on the chart, the blue chart. Radio wave frequencies range from 3 kilohertz to 300 gigahertz. So wavelength is 1 millimeter to 100 kilometers. So something like your radio station would use low frequency radio waves, and they have a very long range, right? So what is it used for? So radio waves can be used to radio waves also includes microwaves as well. So microwaves, just high frequency radio waves. So it could transmit signals from radio stations or cell towers to cooking food in your microwave, right? And this type of radiation is non-ionizing. So ionizing radiation is something like after you use an atomic bomb or a nuclear bomb, the radiation goes on stuff and it doesn't come off, right? So that's ionizing radiation. That type of radiation is harmful, right? Or cosmic rays, that would also be ionizing radiation. And non-ionizing is not particularly harmful or anything. So infrared waves is anywhere from 300 gigahertz to 400 terahertz. So giga is a billion and tera is a trillion. That's what it means. The wavelength is 1 micrometer to 100 micrometers. So these are smaller wavelengths, much smaller than radio waves. And hence they have much higher frequencies. So thermal optical instruments use infrared waves, and you also have infrared imagers on like night vision binoculars or monoculars, and night vision scopes and goggles and whatever. They also have infrared imagers on them, and you use thermal optical instruments in various types of military equipment, like the sights of tanks and stuff like that, for the guns, for the main gun, and guns in general. This type of radiation is non-ionizing radiation. Another application for infrared waves is you would use infrared waves in stuff like a heated, one of those heater things. It's kind of like it radiates heat or something. That would also kind of like use infrared waves. And visible light is 400 terahertz to 790 terahertz, and the wavelength is much smaller. It's 380 to 750 nanometers. Nano means billionth, so that's very small wavelength. And yes, when you go outside, you're getting visible light, right? And obviously, when you get a lot of sunlight, it heats up your skin and stuff like that. So also, we use light bulbs inside our homes so we could see, right? And this type of radiation is non-ionizing, and definitely the frequency of this type of radiation is much higher than radio waves, right? Thousands of times higher than radio waves. Yet when we go outside in the sunlight, is that harmful? It's not, right? I guess some people get skin cancer and stuff because there's also other stuff in visible light, like in sunlight, like ultraviolet, and that is harmful. That has a high enough frequency to cause damage to DNA and stuff like that. So, and which can cause skin cancer. And you have X-rays, and X-rays is from 30 petahertz to 30 exahertz, and these are very high frequency. So 30 petahertz, as you can see in the electromagnetic spectrum chart on the far left top corner. So you see X-rays. That would be anywhere from 10 to the 18 hertz. That would be, I guess, petahertz to 10 to the 20th hertz. So that would be exahertz. And this is very dangerous type of radiation or wavelengths. So the wavelengths is very, very small. It's 124 EV to 124 keV. So this is a very short wavelengths, because it's a very high frequency. So the uses of X-rays can be in the medical field to diagnose problems like fractured bones. If you have any problems with your lungs, the doctor will take an X-ray of your lungs. And if you have kidney stones, they will take an X-ray of your kidney and see if you have any stones or whatever. And it could see right through your body and see what's in there. So this type of wavelength is very penetrating, and this is a type of radiation that you call ionizing radiation. And gamma rays are in space, so if you go into deep space, you're going to be exposed to gamma rays, and that could be devastating to your health, unless you have some kind of shielding. So 5G networks is about 10 times faster than what you have now, which is 4G and 3G in some cases, and the transfer rates can be, I heard, from 1 gigabit per second to maybe 100 gigabits per second. That's pretty damn fast. 100 gigabits per second is about 12.5 megabytes per second. But the problem with 5G is that it doesn't have such long range, so you have to set up antennas every 100 meters, 1 to 200 meters. So since shorter wavelengths, since higher frequency wavelengths, microwaves don't travel as far. They just have to have more of these towers, little towers, like more in smaller intervals. So that's the only thing. But as you can see, as for it being harmful, it isn't. It isn't harmful, you know, because you're exposed to light every day. You're exposed to you know, visible light and invisible light. We're exposed to it, and does it cause genetic damage? No, it doesn't. You turn on your light bulb in your house so when it's darkened because you can't see, and you know, of course it does generate heat, right? When you put your hand near the light bulb, it's hot. So people say that when you put your cell phone in your pocket, it's hot. It's a little bit warm, of course, because it's generating high frequency waves. So it does get a little bit warm, but it's not enough to break bonds in your DNA or anything to cause cancer. So you hear a lot about this nonsense on the internet from uneducated people who don't know what the hell they're talking about, and spreading all this fear and nonsense. And obviously, if you're educated, if you want to educate yourself, you would know that it's just a bunch of malarkey. It's just crap. But anyways, thanks for watching. By Ace 1000KS 1975 signing out.